All right, good day. Let's just review engineering notation. So what we're going to do when the number starts in ordinary notation, we are going to move the decimal a multiple of 3 times until we have exactly 1, 2, or 3 non-zero digits before the decimal. So here's a first example. So if we move the decimal only 3 times, we will get this, 0.00650. This would mean we'd have to include times 10 cubed. This is no good because we don't have 1, 2, or 3 non-zero digits before the decimal. So we move it 3 more times. Now we will have this, 6.50 times 10 to the negative 6. This is good because we have exactly 1 non-zero digit before the decimal. Negative 6 as an exponent corresponds to the prefix micro. So we end up with 6.50 microamps. Here's another one. Okay? We have this many watts. The decimal's at the end of the number. If we only move it 3 times to the left, we get 34,500 times 10 cubed. This is no good. There are too many digits before the decimal. So we move it 3 more times, and that would be 34.5 times 10 to the 6. This is now good. We have 1, 2 non-zero digits before the decimal. We are happy, and we replace 10 to the 6 with the prefix mega. Here's one more. Okay, we start with this many henries. If we only move the decimal 3 places to the right, we still have a 0 out front. The exponent would be negative 3 in this case, but the 0 out front means we have not met this criteria. So we move the decimal 3 more places to the right. Now we get 0.350 times 10 to the negative 6. This is still no good. We do not have 1, 2, or 3 non-zero digits before the decimal. So we have to move the decimal 3 more places. So this is now 350 times 10 to the negative 9 henries. This is good. We've got the criteria met. So we replace 10 to the negative 9 now with the prefix nano. Okay. What happens if we start in scientific notation? Okay, so these are examples of scientific notation. So there's 1 non-zero digit to the left of the decimal and a corresponding power. You can see that these exponents are not multiples of 3. Okay, these are all in scientific notation. So what are we going to do in these cases? We're going to move the decimal to the right 1 or 2 places. Okay, 1 place or 2 places. In order to accommodate a change in the exponent, we're changing the exponent to the closest smaller multiple of 3. So we're going down in terms of the exponent. We go to a smaller one. Okay, and we stop when it's a multiple of 3. So let's take this first example. 1.75 times 10 to the 5. If we move it 1 place to the right, it would be 17.5 times 10 to the 4. This is no good because this is not a multiple of 3. Move it 1 more time, 175 times 10 cubed. This is good because we have a multiple of 3. 10 cubed is kilo. Here's another one. This exponent is -7. If we move the decimal 1 to the right, the exponent becomes -8. See, it's getting smaller by 1. This is no good because -8 is not a multiple of 3. So we move the decimal 1 more place to the right. We get 345 times 10 to the -9. This is good because -9 is a multiple of 3. In fact, 10 to the -9 becomes nano. So we end up with 345 nanofarads. Okay, here's one more. 8.20 times 10 to the -5. Okay, if you move the decimal 1 to the right, you get 82.0 times 10 to the -6. This is good because -6 is a multiple of 3, and therefore 10 to the -6 is in our list of prefixes. It is micro, so we end up with 82 microseconds. So again, you move the decimal only once or twice to the right. If you move it once to the right and you get a multiple of 3 right away, like we did here, then you're done. But if you move it once to the right and you do not have a multiple of 3, then you move it once more to the right and you will have a multiple of 3. Okay? So I hope that helps a little bit. If not, let me know.